Hi everyone, good evening. My name is Ali Asgar and I am the MEP Quantity Surveyor working in Dubai from last 10 years. My major experience is in both pre-contract and post-contract of high-rise buildings. So today's webinar is about our new course, and today we will going to take some essential plumbing technical works. So like MEP, it's a combination of three systems: mechanical, electrical, and plumbing works. So mechanical and electrical works already the course it is there already from last almost like 1 year on our website. And plumbing works is the course which we recently last month we have released, and it is divided into 5 parts. So some of the technical details I'll explain to you. So these are our course for the MEP works, and this is the lesson number 2, which I'll take it now for this webinar, detailed study for the plumbing works. Of course, in this webinar, I cannot take details for the plumbing works, but I'll take like some of the details for the course, and I'll try to explain in front of you. So in this course, there is 5 lessons. The first one is what is the MEP works, how much it will contribute, like how much percentage it will contribute for the MEP works, what are the different types of projects. So all this details, it is covered into what is MEP, which is our lesson number 1. Okay. Then how the MEP works, where it is used, all these important things, it is there in this lesson. Okay, that was our lesson number 1. The lesson number 2 was detailed study for the plumbing system. Okay, so the thing which comes in your mind, what are the plumbing system? Plumbing system, there is 3 system which is used in the building construction works. The first one is the water supply. Okay, so there will be one tank, it is there on the roof, and it will supply the water to each and every flat. So that is, in short, a water supply system. The second one is the drainage system. Whatever the water you are using in the restroom or in the washroom or in the kitchen area, some wastage will be there for the water. So that water has to be disposed off to the building. So that is called a drainage system. The last plumbing system is a firefighting system. Okay, so there is 3 things: water supply, drainage, and firefighting system. Firefighting system, we all know that it is a part of a sprinkler system. So if there is any fire, it is there inside the building, so you can overcome with that fire. So that is called a firefighting system. So plumbing system, it is divided into 3 parts: water supply, drainage, and firefighting. Okay, let's start with the water supply works. Okay, so for supplying of water inside each and every flat, there will be so many things will be there. Like there will be pipes, there will be pumps, there will be water tanks, water heaters, walls, accessories, sanitary waste, so many things it is there. Okay, so I'll just try to explain from a one schematic how in a bigger picture how the water supply system works inside a building. And I'm taking an example for the high-rise building. If there is a residential building for G+20 floor or G+40 floors, I'll start first from here, then I'll go to one drawing and I'll try to explain from there. Okay, for an example, I have one building in front of me, which is 15th floor. Okay, so what are the components will be there for the plumbing works? The first one is a concrete water tank. So every water supply in a building comes from a government. There will be one centralized government will be there for every country. From there, the water, it is coming to every building. Okay. So first, the water will be stored inside this concrete tank, which is located at the ground floor. Okay. The second thing will be a transfer pump. Okay, once the water it is stored inside this concrete tank, there will be one transfer pump which will supply this water to one secondary tank which is called GRP water tank, and that is located on the roof. Okay, the first thing is the government. From the government, you will get the water. It will be stored in the concrete water tank. Then it will be transferred through this transfer pump to a GRP water tank. Okay, from this GRP water tank, it will supply to each and every floor. So here the one pump, it will come into action, which is called a booster pump. This is the transfer line. Once this water is filled, it will be supplied to each and every flat. Then you will have one booster pump. Booster pump is used to boost the water to top 3 floors. Okay. And then after, the gravity line is used for remaining floors. What does it mean is, when this GRP water tank, it is supplying the water to each and every flat. So this is G plus 15 plus roof building. Okay. So the tank is located on the roof. So once who is living on 15th floor, he'll not have the enough pressure of the water. Okay. So for the tenants who is living on the 15th floor, we are using one booster pump. Even for the 14th floor also, you will not get that particular pressure. Okay. So for that also, the water supply for the for top 3 floors, the 13, 14, and 15, it will be a boosted line. Okay. To increase the pressure of the water. But after the 13th floor, once the water it reach to the 12th floor, it will have an enough pressure will be there. Okay. So always for every high-rise building, there will be 3 water supply line. One will be the transfer line, which will supply the water from concrete through transfer pump to the JRP water tank, which is located on the roof. And from the roof, there will be 2 lines will be down. One line will be for top 3 floors or top 4 floors. Depends how much the pressure it is required. Okay. Depending upon the number of flats also, how many flats it is there. If it is more flat on the 15th floor, then top 3 floor only the consultant may use for the booster line. But there is less flat on the 15. Okay, each and every floor there is less flat, then the boosted line will be, the boosted floors will be more. Okay, so this is what it is. This booster pump will be used for to increase the pressure of first 3 floors. Then after it will be used, the remaining floor will be having a much pressure, and it will be flowed through the gravity line. So there will be 3 line: transfer line, boosted line, and gravity line. In front of you, I'll just open one drawing for one of our projects. Okay, so it will be like it's easy for everyone to understand. So what is happening over here? So let me explain to you first. This is a building which is 21 plus roof. So this building will have a 21 floor, G plus 21. So I'll just zoom out here and I'll go to the ground floor. Okay, I'll zoom in this part. This is the water supply which is coming from the government. DEWA incoming water line. DEWA is a Dubai Electricity and Water Authority. I'm working in Dubai, so here DEWA, DEWA, Dubai Electricity and Water Authority. They are the one. This is the government who is supplying the water for each and every building. Okay, and this is the plot limit in front of you. Please keep yourself muted. If you have any questions, I'll take it at the end. Okay, so let me explain first. So this is the plot limit. Okay, from here we need to connect this line. This green color you can see on your screen is going the DEWA incoming water supply line to this particular tank, which is our concrete tank, which you can see over here. This is the tank. This is the concrete tank. Okay. Through this concrete tank, there will be transfer pump will be there. CWTP, cold water transfer pump. So these are the vertical turbine pump, which will transfer this cold water supply transfer line. This pink color you can see on your screen, it will go till the roof. You can see over here, 110 cold water transfer line. So this will go at the top. Okay, if you follow this, it will go to this GRP water tank. So you can see over here, GRP roof domestic water tank 2 partition. So there will be 2 partition. In between, there will be 1 partition will be there for this tank. And it is 50 meter cube, the total capacity of this tank. Okay. So over here, once the water is filled through this line, there will be 2 lines. Okay, 2 lines you can see over here. One line, it is coming out from here, which is cold water supply. Okay, which is going here. This is the line. And the second one is cold water boosted line, which is connected through here, through this booster pump. This is the cold water booster pump, 1 duty, 1 standby. Always a consultant will design a pump in such a way, 1 duty and 1 standby. always one pump will be in working condition. Like always one pump only will be working, other one will be standby. It will not be under working. If there is any maintenance will be there in one pump, or any pump will be damaged, or any maintenance it is there in one pump, then this flow will be transferred to the other pump. Okay, and this pump will go in under repair. So this is why the water distribution should not be interrupted. Always there should be continuous distribution of the water should be there. That's why always the consultant put like one duty and one standby. Always one pump will be under duty, one pump will be standby. If there is any problem in or any maintenance in the one pump, then the water will be transferred to the other pump. Okay, so this is what the concept it is there. And there is so many accessories it is there, isolation wall, NRV, then there will be one expansion tanks and all it is there. This everything associated for this pump, I have already explained in detail in my course. So once you enrolled into our course, you'll see all in detail, like what are the types of pipe it is there, how this 110 or 80 pipes it is there, what type of tank it is there, underground water tank, above ground water tank. Then there will be insulation on the tank. What will be the size of this tank? How the partition is done? What are the supports? Then what are this? What is it? The pressurization units? What is the air separator units? This all this thing you will see in the detail. So I'll just give you in front of you the bigger picture, like just an idea how the water supply it works, but all the minute details what you can see over here that already I have covered in our course. Okay, from this boosted line, you can see this green color line. It will go to the first floor. I mean, the 21st floor. Okay, so you can see over here, this is the transfer line. This is the main riser where you can see three pipes. So I have already explained there will be three line, one transfer, one booster, one gravity line. So the same thing you can see over here in the drawing also, you can see three line. One is the transfer line, which is transferring the water. The other one, two lines. The one is the boosted line. You can see over here, it is written ATCWS boosted line. So this green color, it's a boosted line, which is supplying the water to first three floors. Over here, just look into these two lines, this blue color and the green color line. You can see here, this 21st floor is supplying the water from this line. Okay, then if you go down, the same thing you can see is at this floor, the water it is coming from this green color line. Still this gravity line remains the same. Again on 19th floor, the water is coming from this green line, still it is the same. If you go down again on the 4th floor, like on 18th floor, the water it is supplying through this boosted line. And here the boosted line is finished. So first 4th floor, the water is supplying through the boosted line. And down, if you can see from here the water supply start for the gravity line. Okay, so first floor, 4th floor, it's a boosted line. Here the boosted line ends. And the remaining floor, after this floor, at this place on the 17th floor, the pressure of the water will be enough to have a particular pressure in each and every toilet. Okay, so from here the gravity line start supplying the water for every floor. Then down, if you can see, every floor will have the gravity line. Okay, this is the PRV stations and all. So these are all the gravity line. Then after, there will not be any boosted line. Boosted line will be first 4th floor, then after all the gravity line. Okay, so this is what an example in front of you for the schematic for the water distribution system. The second one on your screen is drainage works. It's a small example in front of you about a drainage works. So what is happening over here is, there is two sanitary wares in the restroom. One is the WC, which is toilet, and other one is the wash basin. There will be bathtub also. There will be some kitchen sink also. For each and every sanitary ware, there will be different types of pipes it is used. So the WC pipe you cannot connect with the main waste. It has to be disposed through a separate line, and a wash basin or any kitchen sink it is there, or any bathtub it is there, it has to be separated through some other line. So there will be three lines will be there. The first one is a soil stack, which is a soil line, okay, which is connected to toilets only. this soil should not be connected with any other, it should not be connected with any other waste. Okay. The second line is the waste stack, which is connected to your wash basin or bathtub or anything, any sanitary waste. The waste, it has to be connected through a waste line, and these two lines should not be connected with each other. The last line will be the vent stack. Because once you connect this soil pipe to the WC, this will have some bad smell or bad odor will be there. Okay, so this has to be moved out from the building. So like at your home also, you can see on the top there will be one extended pipe will be there. Okay, and on top of that there will be one cover will be there. Okay, so that is connected to all your soil waste, soil pipe. Okay, so the whatever the smell it is there in this system, it has to be moved out from the building. So that's why it will be terminated to the roof. And there will be one vent call or cover will be there, so that any rain or any water it is there, any rain it is there, so that water should not go inside. This will be a wet pipe. There will be always water in these two lines, but this will be a dry system. There will not be any water inside it, because it will be its main function is only to take a bad smell out from this soil. Okay. So there will be different types of material it is used for this kind of pipes. It can be a UPVC or cast iron. Also, it's one kind of pipe we can use it. Then HDP also we can use it. So many types of pipe, also like UPVC class E also it is widely used. So these are the things. This is how a drainage system works. Then after I have so many things it is there which I've already explained in my course, the water supply, the distribution tanks and all, type of wall, water storage tanks, type of pumps, which is the cheaper one, which is the expensive one, what are the material and types of these walls. Okay, what are the types of these things and all. This all everything what you can see on your screen, this all, I'm not hiding anything. This all everything I have explained in my course. Now we will jump into a firefighting works. Okay, what are the firefighting works which is associated for a building? So the same thing how I've explained, I'll start with the schematic for the firefighting works. So again, I'm taking an example for G+15 floor. How the water it is there, like always the concrete tank, it will be divided into two parts. One part will be supplying the water, will be used for the potable water, and other part will be used for the firefighting works. Okay, there will be one fire pumps will be associated. This is the main pipe, and every pipe will be having a like it will be connected to one sprinkler through one ZCV, and these are the sprinklers which we see it all over the building, whether it is inside the corridor or inside the flats and all. So this is how the system works for the firefighting works. Then there will be one more separate system. It is there in case of any fire inside the building. There will be one breaching inlet where the fire department will come with their tanks. This tank, once the water it is finished, this firefighters will connect their pipes over here, because they will have a lot of external tanks will be there, and they will supply the water inside the building through the breaching inlet. And these are the FHC, firehouse cabinet, and you can see all over the building, inside your corridor, inside your basements and all. There will be one reel will be there, 60 meters, and in the box. So it will have a nozzle. So wherever the fire it is there, you can spread the water on it. Okay, so it will, like, you can overcome with the fire. So this is how a complete firefighting system works. So what are the type of pipes to be used? What are the components associated with the ZCV? What is ZCV? What are the different types of sprinklers used inside the building? What is FHC? What are the components it is there? Okay. What is breaching inlet? What are the firefighting tanks? What kind of fire pump set it is used inside the building? Okay. Because like once the fire it is there inside the building, the electricity will be cut off to the building. Okay, so there should be a combination of the pumps will be used inside the firefighting system. Okay, it's a diesel, electrical, jockey. So this kind of pumps it is used. So all this thing I have already explained in details in my course. So this is what an introduction, an essential technical study for our